So my name is Mai and I'm from Australia. So what do you get when you add Australia with the Olympics? Anyone know? Breakdancing, that's right. Who wants to see some breakdancing today? Just joking. But all jokes aside, what myself and my co-speaker Sai is going to do today is talk through some of the Amazon ECS best practices. We're going to break down the ECS security best practices for you and automate that via your CI/CD pipeline so you don't have to do the heavy lifting. And with that, I'm going to hand over to Sai.
Thank you, Mai. Hi, everyone. As a solution architect, every day I work with customers in designing container solutions. And in every architecture, the security is the primary discussion that we have. And sometimes customers say that containers bring unique security challenges. So what we're going to do today is, what are some of the unique security challenges that containers bring? And what are some of the 3 common points that we are going to solve? And we will dive deep into how we are going to solve those security problems. So let's get into it. So starting with container security challenges. We know that containers are scalable. So we deploy lots and lots of containers based on the incoming traffic. We scale out, we scale in. So at any given point of time, there are lots and lots of containers. And containers are short-lived. Due to their ephemeral nature, containers are short-lived, and it is very hard to pinpoint any security threat that might be running inside a container because at any given point of time, they are not there anymore. And they're different, right? In a single environment, there are lots of containers running, but they might not be running the same application. We have front-end application, back-end application, and so on. And the same security measures might not be suitable for all the different types of applications running in a single environment. And insecure sources. How many of you are using golden images in your environment today? OK, thank you. When it comes to containers, we pull the Docker images from public sources as well, right? So there are times that it could be pulled from an insecure source. And due to lack of expertise, level of access, and lack of visibility as well. In containers, we don't get a full visibility of what's happening in it because the container's job is to come in, do the task, and exit. So we have to implement logging and other observability tools to understand what has happened in the past, to understand exactly how a container is performing. So because the containers are scalable, they're short-lived, they're different and from insecure sources, all of these things are bringing some unique security challenges that can be implemented into in any environment. So what we're going to do today is to resolve 3 common security pain points for Amazon ECS workloads. So are you automating the detection and resolution of the vulnerabilities? And how do you know that your container image is not tampered with? Are you detecting and preventing runtime threats as well? So we are going to dive deep into these 3 topics today. My colleague Mai and I will be covering some of these topics. But before we dive deep into security aspects, let's do a quick refresher on Amazon ECS. Amazon Elastic Container Service is a fully managed container orchestration service that helps customers to deploy, manage, and scale container applications in the cloud. It offers enterprise-grade serverless computing called AWS Fargate. Customers can also deploy containers on EC2 launch type or your own customer-owned hardware using Amazon ECS Anywhere. Amazon ECS is simple, yet it is powerful. Since Amazon been there for a long time, we have been seeing over 2.4 billion Amazon ECS tasks launched each week. And over 65% of the new container customers use Amazon ECS. And majority of them running workloads in AWS Fargate. Can I know how many of you are using completely AWS Fargate on Amazon ECS? All your workloads. Thank you. And another important note is Amazon ECS launched over 77.2 million tasks for Amazon Prime Day 2024. So you can see how big it can scale while being very simple and easy to deploy all the containers in the cloud. Let's do a quick refresher on AWS Fargate as well. AWS Fargate is a serverless compute for containers. It offers isolation and security by design. There is no upfront cost. You only pay for what is running or being used. And you can also use Fargate Spot and Graviton for cost-effective workloads and savings. Now let's talk a little bit about security on the Fargate. When using Fargate, there is no container host to upgrade or patch. There is no cluster capacity management as well. So you don't have to create any auto-scaling groups and worry about what instance type or what instance size you will have to launch in order to run your containers. Improve security through isolation, which means each task on Amazon ECS is going to run in a separate kernel when you use AWS Fargate. As you can see on the right side, the shared responsibility model with AWS Fargate is customer is only responsible for the customer data, applications, IAM, which is identity and access management, and network access and firewall configuration. By using AWS Fargate, you get isolated compute, dedicated ENIs, dedicated storage, credentials are scoped to applications, and infrastructure is always patched. Now let's get into containers. Now that we know Fargate is automatically bringing some of the security features into Amazon ECS, now when we run containers, let's take the shield right strategy. That is, starting from container images, then moving to containers, and then Amazon ECS tasks. In the container images, if you're using Amazon ECR, Elastic Container Registry, a fully managed container registry service, you can enable immutable tags. By enabling immutable tags, you can prevent overwriting or deletion of an image tag of the Docker image in that particular registry. So this way, you can make sure we can easily reference which container image is running in the environment, and you can also make sure that the images are not tampered with any malicious tags, or if someone has accidentally made changes to the tags unintentionally. So immutable tags will help you in prevention of overwriting and deletion of the image tags. And enable image scanning. Amazon ECR offers both basic scanning and enhanced scanning. We are going to dive deep into that today. Image signing as well. So this is how you know that your Docker images are not tampered with. So only signed images are deployed into your environment. If it is not signed, then it is automatically rejected. And software version consistency. Anyone using ECS, anyone is aware of the software version consistency? This is one of the new features released recently. Okay, so with software version consistency, when you're using Amazon ECS service with ECS deployment controller, software version consistency is there by default. So it will ensure that the same image digest is deployed throughout the deployment or throughout the life cycle of the deployment of an Amazon ECS service. So even if the new deployment is referencing a different image tag. So this way, you can always make sure that the same image digest is running throughout the life cycle of the deployment. So even if someone accidentally or purposefully making any change to the image digest, that is trying to use a different Docker image in the new deployment, it is still going to point to the original image digest of that throughout the life cycle of the deployment. Now let's move to the containers. So in the containers, always use no privileged mode. If you are using AWS Fargate, only no privilege mode is supported. By using no privilege mode, you are not allowing container to get access to the container host. In AWS Fargate, that is not possible, but if you're using EC2 launch type, use no privilege mode so that the container will not be able to access the container host and will not be able to make any changes on it so that all the other containers running on that particular host will not be affected. Use non-root user and read-only file system wherever it is appropriate, and implement runtime monitoring. On the Amazon ECS tasks, you can attach and manage security groups, both inbound and outbound rules, so you can make sure that what endpoints your Amazon ECS task needs to access. And use secrets and do not store any sensitive information in the plain text, especially in the environment variables. So if you have some sensitive information, use secrets in that particular area. Then we have task role and task execution role. This way, you can make sure that a specific application is only having access to the defined AWS service. For example, if you need an application that needs to access Amazon S3, use task IAM role. This way that application only have access to S3 or a specific bucket or a specific object in that particular bucket. And then implement container logs. Now that the container is running, as we talked about, the containers are short-lived, we definitely want to know how the container is performing, so make sure that the container logs are implemented. So now let's dive deep into container images. So for that, I'll be handing it over to Mai, who will be diving deep into implementing and automating security vulnerabilities on container images.
Awesome. Thank you very much, Sai. So we're talking about container images, right? So let's talk about why do we need scalable vulnerability management, right? So if we rewind back 10 plus years ago, I used to be a systems administrator for a large hospital. And this is at the time when WannaCry was around as a vulnerability. And I was tasked as a sysadmin to make sure that our virtual machines on premises at that time was patched and some workstations were patched. Now the problem with the workstations were that they had intermittent network connectivity. Now, although I can apply some automation with patching my virtual machines, I had to go and find these workstations scattered across the hospital. So that meant when I found the workstation, I had to stand there and wait around for patching to be completed. So much for scalable vulnerability management. It took me weeks to actually complete patching. Now, fast forward to 2024, replace the virtual machines with container images. Now, who knows off the top of their head all the software components that are contained within your latest container image? Hands up? Not many people, right? So what about the vulnerabilities that could be associated with those software components? There could be a few. So as your business scales, you are going to be managing a lot of container images. So it's going to be quite cumbersome to look after your container images and the potential software vulnerabilities. And what about if you're working with public sector or financial services? You have to look at some of the compliance requirements as well, right? And if you're expanding globally, you might have some local compliance requirements that you need to meet. Now, speaking of manual processes, right? How do you get on top of these vulnerability responses quickly? So even if you have alerting enabled within your any vulnerabilities that have been picked up, how do you keep on top of them? Because you might be experiencing alert fatigue. Sounds familiar, right? Now, this is where Amazon Inspector can help. So Inspector is our native security tool that helps you scan through your potential vulnerabilities for your container images stored in Amazon Elastic Container Repository or Registry. It also is interactive with AWS Lambda functions and Amazon EC2 instances as well. So it does all the scanning in real time. And in terms of prioritizing some of your vulnerabilities that you need to remediate, it has an Inspector risk score that you can actually look at as well. So you can remediate those quickly. And what about scaling out, right? So best of all, with Inspector, you can enable that in just one click across all of your AWS accounts within an AWS organization. And best of all, SBOM. So who's heard of SBOM? Yeah, so SBOM stands for Software Bill of Materials. So you can manage your Software Bill of Materials list in a central location. So that's great news for DevOps teams and security teams alike. And you can automate your workflows using the Amazon Inspector API endpoints, as well as integrating that with Amazon EventBridge. So that is our Event Hub service. So if you wanted to remediate your vulnerabilities automatically via AWS Lambda functions, you can do that also. And best of all, you can have all your alerts within one single location with integration with AWS Security Hub. So let's talk a little bit about the Software Bill of Materials, or SBOM, right? So the SBOM is basically a nested list which contains a lot of your software dependencies and libraries. And SBOMs can be exported for a single resource or across your bunch of resources across multiple AWS accounts as well. And you can also integrate that with scanning for your operating systems, as well as additional programming languages. And you can do all this for free. And best of all, you can do some further analytics with native analytics services like Amazon Athena, which is our standard SQL querying tool, and Amazon QuickStart as well. So if you want some visualization around your findings, you can do that. So let's take a look at how that integrates with your existing CI/CD tools. So who uses GitHub, TeamCity, or Jenkins? Yeah, quite a few of you. So you already have the tools that you're using for CI/CD. You can integrate Amazon Inspector into your CI/CD tools. But what if you're not using those three tools that I just mentioned? You can create your own custom orchestration tool using the SBOM generator API of Inspector. And best of all, you can use Inspector features such as scan on push and continuous scanning, so you can keep on top of zero-day vulnerabilities as well. So this is what it looks like when you integrate your Inspector SBOM into your CI/CD pipeline. So you start off with your Git repo, and that's where your code base lives. And what AWS Code Build does is it packages up your container image, and before it gets pushed out into your ECS workload, Amazon Inspector takes that container image and scans it for you. And then it generates the SBOM JSON file. And alongside that, it looks at any vulnerabilities if it's associated with your software components. And then it stores it to Amazon ECR. So it stores that container image there and finally gets pushed out to Amazon ECS on Fargate. Now, all the while, AWS Code Pipeline helps with that orchestration. So let's take a look at what this looks like in terms of a demo. So we're starting off with AWS Code Build in the console, and we're going to be looking at our build profile. All right, so I'm going to go through and have a look at the buildspec.yaml, and I'm going to be adding some inspector build commands, so it will generate this SBOM file for us, as well as the vulnerabilities list. And once I've saved that, I'm going to go ahead and go to AWS Code Pipeline and trigger my pipeline. All right, so we're in our code pipeline now, and what we're looking for is a successful result. And once that pipeline is green and completed, we're going to go into the build logs, and what we're going to be looking for is the word SBOM and inspector. So help me find those words in the build logs in a second. Okay, hopefully you can see SBOM in there and inspector. And if you see that, that means inspector has triggered and it started to scan through our container image, looking for all the software components and dependencies and any vulnerabilities. All right, I'm happy with that. Let's go ahead and move on to the actual JSON file that is outputted. So that's going to take us to Amazon S3, which is where the JSON file is stored. And what I'm going to do is I'm going to be using a JSON visualizer so you can see what it looks like. So I've got 117 components already, which is great. So what you're going to see is a lot of metadata up there. So what the description is of the software component, and you can see a lot of Debian libraries in here, which is expected because it's built on Debian in this case. And let's say you're looking for a software component like log4j. Anyone remembers that? Yeah, so this will be very handy if you're looking for certain software components. Now let's move on to the vulnerabilities that it's detected. It's detected 2 vulnerabilities for this image. And you can see the description as well as the vector, as well as the inspector risk score that I just talked about, and the severity. This will help you prioritize what's important for your business. And if you wanted to dive into the description, there's an advisory URL that you can hop into. and any other recommendations, as well as what are the next steps in order to remediate this particular vulnerability. So this is one way of looking for vulnerabilities through this JSON file, right? There is another way. And in a second, we'll be going to the AWS console, going to Inspector, and taking a look at the vulnerabilities through there. So you have options. All right, so we're in the critical findings page, and we're looking at 4 critical findings from the container images stored in ECR across multiple container images. So let's take a look at the top one, which is the Spring Framework vulnerability that is picked up, and let's have a look at the overview. Okay, so it gives you the details around what are the CVEs, what's the inspector risk score that we talked about, what are the next steps, and what resource it was affected, as well as the packages. Now, what you saw end-to-end was incorporating Amazon Inspector within your CI/CD pipeline, so you can find out exactly what the software components are in your SBOM and the vulnerabilities that are associated with it. All right, question to the audience. Who's ever downloaded a container image from a public registry? Yep, quite a few of you. So, if you can imagine a scenario where your manager comes up to you and says, hey, I want this WordPress site up and running by close of business tomorrow. And you're like, great, that's a great use case for running on containers, especially on ECS, right, on Fargate. And then, as any IT professional does, what's the first step? Yeah, Googling. So you go ahead and Google, and you're going, okay, WordPress container image. And you see one thing, and you're like, okay, let me download that. And you're furiously working away to get this WordPress site up and running by close of business tomorrow, right? So the last thing on your mind is, does this container image come from a trusted source? Can I trust this container image? Does it contain vulnerabilities, right? And that's a common question and a concern from the security and compliance teams. And that's why you should be friends with them. But jokes aside, that is a real concern because it could impact your organization, right, in terms of security. And similarly, your DevOps team might be concerned around that as well, because they're the ones that are going to be called after hours to go and fix this, right? Unless you're part of DevOps yourself. So the question remains, how do we know that your container image comes from a trusted source? So the answer to this is signing and verification. If you sign and verify your container images, you know it comes from a trusted source and is not been tampered with. And this is an industry standard technique. So what do we mean by a trusted source? So trusted source means that if you can imagine your own private Git repo for your organization and your CI/CD pipeline, anything that comes from outside of that is an untrusted source, which is fair enough. Now, before we talk about the next steps around signing a verification of your container images, let's talk about your actual container image itself, right? So your container image contains a digest of the content. And that's contained within a JSON file, which is called the manifest, right? Now, what do we mean by a digest? So a digest is when you apply an encryption algorithm like hashing in order to generate a secure string which is unreadable unless you have a key. And with hashing, it's an encryption algorithm that uses SHA-256. So what is SHA-256? Well, let's say you have a 512-bit string of data and you run SHA-256 on top of it to encrypt it, you end up with a 256-bit string. So it's always a fixed length, this secure string. And again, with container images, there's container layers, and each layer has its own digest. So if you can imagine any part of your container image or your layers being changed, that means it's a brand new object. So you'll see what I mean in just a second. So this is an example container image manifest. And as you can see, there is a digest for the top layer, and each of the different layers have its own digest. And you can imagine if someone tampers with your container image, that means that your digest changes, right? Now, in order to do signing and verification, there are two major components. The first one is Notary. So that's the hardware component that helps with your signing and verification. And Notation looks after the software component of signing and verification, and it is part of the CNCF open source tool. And both of these components work together in order to help with your end-to-end signing and verification process. So let's go ahead and take a look at what that looks like. So looking at signing, so you're going to start off with your container image, and the first step is hashing. So we'll do some hashing, and then it generates that digest, right? And then the second step is encrypting that with a private key. So simple, two-step process. And then you end up with a signature and your container image, which is going to get stored in your container registry. Now, what about verification? So when you sign, you always need to verify, right? And the first step is to download that container image stored in your registry alongside your signature. And then from that signature, you need to extract the public key associated with it. So when you extract that public key, that actually corresponds to your private key. But your public key will help you decrypt that manifest file, and then you compare that manifest or the digest contained within the manifest and the downloaded image and the manifest, the digest there. So if those two matches up, that means that your container image has not been changed. So this is, again, another two-step process. Now, hopefully everyone's been taking notes, because I'm going to ask each and every one of you to implement this right now. No, just joking. But if you can imagine, try to do that, try to do each and every step of that process, right? It's going to get really overwhelming. Now, add on top of that, the public and private keys that you have to manage, that can get really difficult. So this is where AWS Signer can help. AWS Signer will help with the life cycle of signing and verification each step of the way. And best of all, you can manage your public and private keys in the central location, and you can store your signatures alongside your container image within Amazon ECR. So again, great news for security and DevOps teams alike. So this is what it looks like when you incorporate AWS Signer into your CI/CD pipeline. Again, you saw the first half where Inspector was enabled in order to generate this SBOM file, right? And the vulnerabilities list. Now we're going to be looking at the area under the red circle, red square. All right, so you have AWS Signer here, and we're going to sign and verify your container image before it gets deployed into ECS. If there is no signature or it hasn't been verified, then your whole pipeline will fail, therefore it won't even get to ECS. Okay, so let's take a look at the demo of what this looks like end to end. So in AWS Signer in the console, we're going to be creating a signing profile. And I'm going to be assigning a profile name and selecting notation for container registries. Remember, we talked about notation being an important part. So you're going to see that quite often. And once we save this profile, I'm going to go to the ARN, and using that ARN and incorporating that within my build.yaml profile. Okay, so I'm in my private Git repo, and I'm going to be editing my build spec.yaml and adding some build commands in there. And you're going to see a lot of notation being mentioned again. So we talked about notation being an important part of each of the steps. and using my AWS signer profile in order to facilitate the signing process. Okay, so that's the first half. As you can see, there's the mention of a public key involved in there as well. And then I can't forget about the post build to actually trigger the signing of my container image. So once that is added, I am going to commit this file. And the next step is, we can't forget about signing, and then after signing, we need to verify. All right, let's go ahead and verify that. We're going to go into the deploy.yaml, and I'll be adding similar steps, so using notation and AWS extensions in order to help with the verification process. And again, using AWS Signer and the profile in order to help with verification. Again, there's mention of the public key and using the trust policy as well. And once again, I shouldn't forget to add the verification process of my container image and the signature associated with it, right? Before it gets deployed. Very important step. So once I'm done with that, I'm going to commit this file again in Git. And this should trigger my pipeline automatically because my Git repo is tied to my code pipeline. Okay, so it's automatically triggered my pipeline. And once it turns green, what we're going to be looking out for is the build logs initially. So I'm looking for successfully signed container image. So if you can help look for those details. Okay, let's take a look at the build logs. Moment of truth here. Okay, it says it's successfully signed a container image. Fantastic, that's step one. So what's step two? Verification. Let's go ahead and look at the deploy logs to see if it actually verified my container image. And it has successfully verified my signature associated with my container image. Okay, you can also go to AWS Signer and see the signing jobs for historical information of whether it has successfully signed. So I'm looking for successfully signed, yes it has, and code build has requested this, which is what we're looking for. Okay, excellent. So what you saw end to end is incorporating AWS Signer into the signing and verification process so that your container comes from a trusted source and has not been tampered with. You also saw in the first half of the demo Amazon Inspector and generating that SBOM file that contains potential vulnerabilities so you can keep on top of scalable vulnerabilities management, right? Awesome. Well, shielding right. Now, who has bought cryptocurrency before? No one care to admit? That's all right. Well, let's say you're running containers and some attackers have taken over your containers and running a cryptocurrency mining farm. That's not ideal, right? And that could have severe impact to your organization in terms of security and potential cost implications if you haven't detected that early. So, how do we know that these kind of threats are happening within your container environment, in your runtime environment? With that, I'm going to hand over to Sai.
All right, thank you, Mai. So now that we have discussed about securing container images, image signing, image scanning, and now that the container is in the running state, let's discuss about container runtime security. And that's where Amazon GuardDuty comes in. Amazon GuardDuty is a threat detection service that uses machine learning, anomaly detection, and integrated threat intelligence to identify and prioritize potential threats to your AWS environment. Anyone using GuardDuty today in your ECS clusters? Great, thank you. Amazon GuardDuty offers ECS runtime monitoring, a fully managed runtime threat detection service specifically designed for serverless containers. And one of its key benefits is it is going to remove the complexity that organizations often face in implementing security measures for these types of workloads, like serverless containers. GuardDuty uniquely detects entire attack chains of events using advanced machine learning, not just the isolated events, but it will be able to detect the entire attack chains of events using machine learning. And moreover, GuardDuty detects and responds to threats early, well before they have the chance to escalate into broader systems. So this will really ensure that this will help in keeping the system secure and prioritize security threats. Amazon GuardDuty ECS runtime monitoring helps detect runtime events such as file access, process execution, and network connections that might indicate security threats. It checks hundreds of threat vectors and indicators and can produce over 30 different finding types. For example, it can detect malware infection, cryptocurrency mining, container runtime drift, especially when it comes to container runtime drift. Let's say that there is a new library that was created or modified inside the container during its runtime, right? So that is going to be a container runtime drift. So any changes that you would like to make to the container should always be made through a CI/CD pipeline, and that's the best practice. So if something is happening inside the container while it is running, even that will be found by the Amazon GuardDuty ECS runtime monitoring. And remote code execution, defense evasion, and many other finding types with Amazon GuardDuty. So Amazon GuardDuty ECS runtime monitoring provides enhanced threat detection, and it will give you a lot of information that can easily help a security engineer find out what is happening with the container and implement remediation steps. For example, in this case, a resource that connects to command and control host. Command and control host refers to a server or computer system that is used by cyber attackers to control compromised devices on a network. So in this example, there is a resource that is trying to connect to command and control host, and this is one of the finding example that GuardDuty is showing us. If you see in this example, it is giving us a lot of information, including what is the container that is actually affected with this, what is the Docker image that was used, what is the SHA-256 hash, and it will also show what is the cluster name, what is the namespace, parent process, path that is being executed in this particular container, including the process ID as well. If you see in the container context area, initially we discussed that containers are scalable. So when you have lots and lots of containers, it is very important to find out which specific container is having this particular security threat. So GuardDuty is going to easily help you with that particular finding type, and it is also going to be an early detection of compromise. So how is GuardDuty able to get that particular information? GuardDuty uses a lightweight, fully managed security agent that adds visibility into individual container runtime behaviors. For customers who is using AWS organizations, I'm pretty sure that you have lots and lots of ECS clusters, and enabling GuardDuty on each cluster could be difficult. So you can simply enable GuardDuty ECS runtime monitoring on the organization level itself. So when you enable there, it will automatically enable for all the ECS clusters in that particular organization, which makes it just a one-click setup. And Amazon GuardDuty, this runtime agent is a fully managed, which means you don't have to worry about patching it, securing it, and whenever a new task is coming up, we always use the latest patched ECS agent, runtime monitoring agent. On top of that, all the analytics are done on the back end. So you don't have to worry about any performance issues for your tasks, which means in your task definition, you don't have to give extra CPU or extra memory units for this particular GuardDuty. Because all the analytics are done on the back end, you can completely focus on your task itself or on your application itself for CPU and memory units. Also, there is a console where you can see what are all the clusters that this coverage is running on. So let's say you have thousands of clusters. You can simply come to this particular console and see which clusters is being enabled with ECS runtime monitoring, which are not. So if you would like to, if a DevOps engineer simply have a good glance of what's happening, this console will give you a lot of information. Now let's talk about how we deploy this GuardDuty agent. So in the context of when you're using Amazon EC2 instance, GuardDuty agent is deployed manually. You can bake it into an AMI, or you can use GuardDuty's provided AWS Systems Manager document. And GuardDuty agent is going to be deployed as a daemon set in the EC2 instance. Once it is deployed as a daemon set, you will also have to configure VPC endpoints. This will help GuardDuty receive the runtime events of your Amazon EC2 instances. Now, when you use AWS Fargate, it is going to be even more simple. You can simply navigate to Amazon GuardDuty console and enable runtime monitoring and enable GuardDuty agent management. So when you enable agent management in the console for ECS Fargate, it is going to automatically pull the GuardDuty agent Docker image from Amazon ECR, and it is deployed as a sidecar container along with your task. So again, you're not going to give any extra CPU or memory units for your task, and every time a new task is deployed, it is always pulled from the Amazon ECR, which is an upgraded and patched version of the ECS agent runtime monitoring. Also, all the VPC endpoints will be configured automatically when you use ECS Fargate, and you don't have to worry about creating the VPC endpoints as well. So these VPC endpoints will be used to receive the runtime events from the particular task. So now that we discussed about GuardDuty and some of its findings and how easy it is to deploy ECS runtime monitoring, Amazon GuardDuty runtime monitoring agent with AWS Fargate, let's take a quick demo to understand how it is going to be done in real time. Okay, I'm navigating to GuardDuty console. So now that in the GuardDuty console, we are landing on a summary page. Here on the left side, I click on runtime monitoring, and I am enabling runtime monitoring on Amazon GuardDuty. Next, if we see here, we can see AWS Fargate ECS only. So when we enable this is the automated agent configuration for ECS Fargate. So as long as this is enabled, any Fargate task that is going to be launched in Amazon ECS, it is going to have a Amazon GuardDuty agent deployed as a sidecar container. Now let me navigate to ECS console. Here I have one cluster, retail store ECS cluster. And now let me show you the task definition that I'm going to use. The task definition name is frontend. So now that we have a cluster and a task definition, now let's go ahead and start a task. So I'm going to use AWS CLI command using the run task API call to start a task. I'm going to run that particular task in the retail store ECS cluster using the front-end task definition that I just showed you, and it is going to be a Fargate launch type. So let me hit enter, and then let's see that the Fargate task is going to be in running state shortly. Now let me navigate to the ECS console. And let's go to clusters page, and here let's verify if the task is already started. Now inside tasks tab, we can see that there is one task running. If we click on that particular task, we can see that there are two containers that are in running state. As you can see, my application is only front-end app, but there is also another container that is running, which is sidecar container called AWS GuardDuty agent. So this is automatically deployed with this particular task since we have enabled automated GuardDuty agent deployment on the Amazon GuardDuty console. So since you have lots and lots of deployments, right, every time it is going to pull a latest Docker image of that GuardDuty agent, so you don't have to worry about whether you have to patch it or secure. That's why we call it a managed GuardDuty agent. Now let's navigate to GuardDuty console and see what are some of the findings that GuardDuty was able to find. As we can see, there is already one finding in the summary page, and which is showing it as a high severity finding. Now let's click on that view all findings, and we can see that it is a CNC activity, that just like we discussed some time ago. So if I click on that particular finding type, I get more information here with a description saying that a process is querying a domain name associated with a known command and control server. In the overview page, we can see which region, what is the account ID, and we can see what is the resource affected. In this case, it is ECS cluster. What is the cluster name? And we also see the task details, especially the task ID. And we also see what is the task definition that was used and the launch type as well. In the container section, it is going to show what is the container runtime that was being used, and what is the container name, and the image that was used with this particular container for your application. And in the action, you can see what exactly is happening with this container. So it is a DNS request, and it is querying that particular domain. And in the process details and the runtime details, you can see that it is using curl. You can also see the executable path, which in this case it is user bin curl, and you can see process ID and which user is actually running that particular command. So with all this information, it will be very easy for a security engineer to go and check which container is actually having an issue, what Docker image is being used, where they're using the right task definition, what is the image digest, what is the SHA-256. All this information will be very helpful for a security engineer to find it out. Now let me go back to the AWS documentation, which shows some of the runtime monitoring finding types. So here, if we click on the CNC activity finding type that we just found out with Amazon GuardDuty, we can see we can get more information about that particular finding type, including it says that a container is querying a domain name that is associated with a known command and control server, and it will also give some of the remediation recommendations in that particular documentation. So with that, we have discussed about how easy it is to set up Amazon GuardDuty runtime monitoring, how easy it is to deploy Amazon GuardDuty agent with AWS Fargate, and what are some of the finding types that Amazon GuardDuty can give us that will help security engineers to quickly find out which specific container is having an issue. So with that, I'll be handing it over to Mai to share some of the learning resources on ECS security best practices. Thank you.
Okay, sick. All right, hopefully this microphone stays in place. All right, so in summary, you can use Amazon Inspector in order to scale out your vulnerability management using your CI/CD pipeline. And you can use AWS Signer to know that your container image comes from a trusted source and has not been tampered with. And last but not least, you can use Amazon GuardDuty so you can scale out your runtime security across your ECS workloads. So where do you go to learn more about ECS best practices? Go to this QR code, and this will take you right to the ECS best practices white paper, as well as being able to run the well-architected Amazon ECS custom lens. And then last but not least, you can build your own demo using the AWS Signer and Amazon Inspector for ECS workshop. So I hope you got that one. All right, thank you for listening to us. Make sure you complete the session survey. And if you see any one of us, make sure you give us your best breakdancing moves, right? And with that, make sure you're building securely on Amazon ECS. Thank you very much.